So in this example, I want to find all of the complex zeros of the polynomial function given for you here. The process that we're going to go through and use is exactly the same as it was when we tried to find the real zeros, except we get to a point where we just have to now account for complex values. So we're going to start out by finding what is the degree of my polynomial. You can see here that this is a fourth degree polynomial, and therefore I have at most four possible roots. And we're going to go in and we're going to make a list of those possible roots using my p and my q terms. So p is the constant at the end of the function. P looks like plus or minus all of the factors of 20, plus or minus 1, 2, 4, 5, 10, and 20. Now because the q term that I have here, because the q term that I have here is a coefficient of 1, we can easily see that my possible roots are going to come from this list here, my list of all q's. So let's go and let's enter this polynomial into the y equal portion of my calculator and find the first root. So I have entered into the y equals, the polynomial that we're discussing. I'm going to go to the table and I'm going to enter in the first possible root. So I would have a -1, and that doesn't give me 0. So what about +1? How about -2? Yes, I do get a 0 at -2. So I know that I'm going to have to do this twice since this was a fourth degree polynomial, because each time I do synthetic division, remember, that reduces my polynomial by 1 degree. So if I do synthetic division one time, I get x cubed. If I do it another time, I get x squared. So I'm going to go ahead while I'm here on the calculator and I'm going to find two roots. So I know I have a root at -2 and I have another root occurring at 2. So let's write those two possible roots down. We have roots occurring at 2 and -2. And those are the two values that I'm going to use to do my synthetic division. So let's just do +2. And I'm going to bring down the coefficients that I have going on right here. I have 1, 2, 1, -8, and -20. So when I multiply and add, oops, that's not right. I need to bring the 1 down. So 2 times 1 is 2, add, and I get 4. 8, add, and I get 9. 18, add, and I get 10. Multiply, and I get 20, add, and I get 0. So that is my x cubed function, but I have to do it one more time. So I'm going to go through, and I'm going to do this synthetic division again. So going back and picking up the other root that we found in our calculator, we have a -2, and I'm going to use these coefficients now to do my synthetic division, 1, 4, 9, and 10, giving me -2, -4, -10, 0. So this is my x squared. Now I know how to solve or simplify, I should say, a quadratic either using factoring or the quadratic formula. So let's kind of write down what we have so far. I know that I have a polynomial that looks something like x -2, x plus 2, followed by this quadratic, which is x squared plus 2x plus 5. So that whole thing there is this trinomial. Now I know looking at this that there are no factors of 5 that will add to give me 2. So that right there tells me that I have to use the quadratic formula on this section right here to simplify this further. So from here, remember the quadratic formula looks like -b plus or minus the square root of b squared minus 4 times a times c divided by 2a. So that's going to simplify again to give me negative 2. Oops, I'm sorry. Negative 2 plus or minus. This right here would be the square root of 16 divided by 2. Not 16, it's the square root of negative 16. So when I simplify this, I can take the square root of 16, I can take the square root of negative 16, but I'm going to get an imaginary number, right? Because the square root of 16 is 4, and the square root of a negative number is I. So this looks like negative 2 plus or minus 4i divided by 2. Now I can reduce that portion of my fraction just a little bit further, and it's going to look like, because this 2 divides into that number and it divides into that number. It has to divide into both terms or all terms in the numerator evenly, or it has to divide at the same amount into both terms in the numerator in order for it to reduce. So this looks like negative 1 plus or minus 2i. So now what do I have? In other words, I'm going to replace my trinomial into this, but I have to write it in its factored form. Now what does that look like? That looks like, I'm going to show you what it looks like in the long way, and you may not want to do this again, but I'll show you what it looks like, and then you can kind of skip this step next time. Remember that it's x minus this number right here. So it's x minus negative 1 plus 2i, and x minus negative 1 minus 2i. So what do these two terms simplify to be? X minus 2, x plus 2, x, when I distribute this negative here, I get plus 1 minus 2i. And when I distribute it here, I get x plus 1 plus 2i. So this is now my polynomial in its factored form, and that is what I'm asked to find. So you can see that we started out with a 4th degree polynomial. I have at most 4 complex roots occurring here. So it's pretty much the same thing we've done previously with our rational zeros, but we just have to account for what happens when I have complex numbers. Now again, I have one more example for you here that I encourage you to practice on your own and check back with the completed notes to see if you can come up with the same answer.